All right, our final topic in Chapter 8 is angles of elevation and depression. So an angle of elevation is basically the angle that your eyes make from horizontal when you're looking up at an object. So if you ever look up at something, that would be angle of elevation. If you're ever above something looking down at it, you would have an angle of depression. So thinking about the picture here with the lighthouse, if you had the boy looking up and the lighthouse keeper was up at the top of the lighthouse looking down, then they would have the exact same measure of their angles. So angle of elevation is measured this way, and angle of depression is measured this way. So imagine there's a lighthouse keeper up here. I'm going to draw a dotted line. His angle of depression looking down at the boy would be right here. So these obviously, like if you draw their horizontals, are parallel lines because they're both horizontal, and we can see that these are alternate interior angles, so they must be congruent. So there's not, a lot of times it's kind of irrelevant whether you're talking about angle of elevation or angle of depression. They're kind of interchangeable, especially if you have observers at both ends. But what's really important is that both of them are always formed from a horizontal line. So we're never forming these angles from a vertical. We're not doing this angle, and we're not doing this angle. So anytime you see any problem with angle of elevation and depression, just make sure you're measuring your angle off of the horizontal. And if somehow it gives you the vertical angle, the angle from the vertical, that's not an angle of elevation or depression. It could be relevant to the problem, but it is not that. So basically, down here, this angle is not her angle of depression. It has to start from her looking straight out horizontally and then tilting her head downward. So it's basically the angle that your head would go through if you always looked straight ahead and you wanted to look up or down. Kind of like in a video game where you use the right stick to tilt your head up and down, then you're forming that angle of elevation or depression, but it's always relative to your neutral gaze looking straight ahead. Okay, so yes, we know why they are the same measure. They're alternate interior angles. That's pretty simple. This section tends to have lots of word problems because they are giving you scenarios, and this, I guess, is the example of the boy up above. His name was Casey. I didn't realize that. So he's looking at that lighthouse. It's 84 feet tall, so it's 84 here. And he's looking at an angle of elevation of 58 degrees. Remember, that's from the horizontal, so we're drawing this triangle right here, 58 degrees. He is 6 feet tall, and it asks how far he's standing from the lighthouse. So this is something you'll see quite a bit here, is his head is here, but I guess that's him. His feet are here, 6 feet below where the triangle starts. So what we need to do with this 84 is also divide it based on that horizontal line. We have 6 feet down here, and up here we have 78 feet. So in our triangle, when we're doing our calculations, we're using this 78, not the 84, because we're looking at how far above his eye level does the lighthouse go. But in the problem, they gave us how far it is from the ground. When we say 84 foot tall, we mean from level ground. We also, by the way, are assuming that the ground Casey is standing on is level with the ground the lighthouse is on. That's kind of a necessary assumption to make here. They could make the problem a little harder if they said something like, Casey is standing on a 3 foot tall hill. Then that would mean that his ground is actually 3 feet higher than this ground. And while he is 6 feet tall here, this would need to take away 9 feet to account for the hill as well. So lots of stuff you can do with these, but this is pretty straightforward. Trig problem, we have one side measure and an angle of a right triangle. So we want to know how far is he from the lighthouse. That's going to be our x. 78 is our opposite side, and x is our adjacent side. So we're doing opposite over adjacent. That's our tangent function. So we're going to say tangent of 58 degrees is equal to 78 over x. Since x is on the bottom here, we need to multiply it up to the top, and then we're going to have x times the tangent of 58 degrees equals 78. But then we want x by itself, so we need to divide both sides by tan 58 and get 78 over tan 58 degrees. Okay, so I've got our trusty Desmos calculator up again, and we're going to type this in. Keep in mind, this is a precise answer. Like, if we wanted an unrounded answer, 78 over tangent of 58 degrees is a perfectly legitimate unrounded answer. The problem with it is, if we want to know how far is Casey from the lighthouse and we say this, that doesn't have a lot of meaning. Like, none of us really probably has a good idea of what that distance actually is. So we are going to use the calculator, and we're going to round to the nearest tenth here. So we're going to do 78 divided by the tangent of 58. Again, always checking that our calculator is in degrees, not radians. So we would get a very different answer in radians. We'd get 9 instead of 48 feet. So nearest tenth, we have 48.73, so we're going to round to 0.7. So we have 48.7 feet. All right, so we can do a little bit of a judgment call there. We said this angle is 58. Now remember that if that angle were 45, the two legs would be the same. So since the angle is 58, that means it's greater than 45. So this opposite side is taller than this horizontal side, the adjacent side. So it makes sense that we have 78 here and 48.7 here, because this number had to be smaller than that one since this angle is more than 45 degrees. So we can do a little bit of a sanity check even when we don't know anything about the hypotenuse. So all of our problems in this section are going to look like this. I'll do one or two more, but really these are just trig problems in word problem form. So we'll pick two more of these to look at together, and then we'll call that for our notes. So we have Zach standing at the top of a lookout tower. So we're going to go ahead and draw a nice little tower with a Zach in it. And it's tall, I assume. Towers are tall. Okay, tower, perfect, beautiful artwork. He spots a water fountain below. So here is a water fountain, spraying water. Yes, beautiful. Okay. If the lookout tower is 75 feet tall, so here, remember the last problem told us about how high Casey's eyes were above the ground. So when they say the lookout tower is 75 feet tall and don't give us any information about Zach himself, they have to be measuring to his neutral viewpoint. So 75 feet must be to whatever window he's looking out of from the tower. So we don't have to do anything to adjust for his height. It could very easily have said the tower is 75 feet tall and Zach's eye line is 5 feet above the ground. Then we would need to add another 5 feet to form our triangle. But they don't tell us that, so at 75 feet we have our horizontal reference line, and then he's looking down at the fountain, and his angle of depression is 28 degrees. So remember that that's this angle, not this one. I find that we mess this up a lot more with angle of depression than we do angle of elevation. So elevation, for some reason, it makes sense, like we're on the ground, we look up, we draw this triangle. But here a lot of times we want to draw this triangle, which would give us this angle. The problem is that angle is 62 degrees, not 28. So we've got to be really careful that we're placing that correctly. If we drew this triangle, we would need to draw the angle of elevation from the fountain in order for this to work out. So we want to know the horizontal distance to the fountain. That would be here, and that is our adjacent side. If we said someone in the fountain was looking up at him, that would still be the adjacent side of this 28. So these two triangles, the depression triangle and the elevation triangle, are always congruent. They're the exact same triangle, just rotated 180 degrees. Okay, so we have 75 is the height of our triangle. We have 28 degrees, and we have x. Since we have these two, we're going to be using tangent because we're relating opposite over adjacent. You'll find that in these problems, when you're dealing with people at a distance, tangent is by far the most common function that we use in these word problems. Exceptions to that are where we're measuring the actual object that forms the hypotenuse. So the problems that are a wall with a ladder against it, or if you have a road that has a ramp going up and you know the length of the ramp is 20 miles, then that is going to be your hypotenuse, and you would use sine or cosine. But this is probably the most common type you see, which relates these two. So we're going to say tangent of 28 degrees is equal to 75 over x. Again, we need to multiply by x and divide by tan 28, and we get x equals 75 over tan 28 degrees. So back to our calculator, and we're going to do 75 divided by tangent of 28. We get 141. So 141.1 to the nearest tenth. So x equals 141.1, and our units, since we measured the only thing we had in feet, will also be in feet. So let's do a sanity check. So 28 degrees is a lot less than 45, so that means this should be significantly less than x, and it is, so that seems appropriate. That sanity check here can really help you if you mix up where the angle of elevation goes. Because if we had put the 28 in the wrong place, well, I guess then we would have thought that should be longer. Okay, don't mess it up and put it in the wrong place. I'll do one more of these. If you're comfortable with it, because this is just the stuff we've already been doing, feel free to end the video and move on to practicing. But I'll go through one more just because. Here's one with a ladder against a house, so that'll use sine or cosine, so I'll make that our last example. A ladder leaning against a house, makes an angle of 60 degrees with the ground. So that's like an angle of elevation, even though it's not site-based, it's basically the same thing. The ladder is 7 feet from the foundation of the house. That means across the ground, it's 7 feet. And we want to know how long the ladder is. So we can actually use special right triangles here if we wanted to. This is our short side, and this is our hypotenuse, so we could just say x is 14 feet. Now let's say we didn't immediately recognize that 60 is a special right triangle. First of all, we should recognize that. If you see 45 or 60, those are really key important numbers to recognize. They should set off a big warning bell that you can do special right triangle stuff. But let's say we forgot and we just did this like normal. This is going to be a cosine relationship because we have adjacent and hypotenuse. So we're going to write a cosine of 60 degrees equals 7 over x. So what we're going to see here, because we are going to use the calculator to check this, is that cosine of 60 is a half, because we're going to do x equals 7 over cos 60 degrees. So cosine of 60, part of why that 30, 60, 90 right triangle is so special is because the cosine of it is a very nice round number that is 1/2. So let's just type it in without the 7 and do cosine of 60. See, and we get exactly 0.5, which is just beautiful. Good thing. So if we type in 7 over cosine of 60, that's 7 over 1/2, which is 14. Yeah, so that is it. That's going to be the last one I go over. There's plenty more practice, lots of word problems here. So if you feel uncomfortable with word problems and need more practice, absolutely go through and work those. They're just basic trigonometry problems. Once you turn the drawing in, or the words into a drawing, they're all very, very simple problems.